Hello, welcome to my channel. Today I'm going to be teaching you how to solve simple linear equations, literal equations, and working through a few word problems. Alright, so the first thing I want to know is that all simple linear equations are going to take the form mx plus n equal p, with the solution of that just being x equals p minus n divided by n. Okay, so first up, the first thing that you want to know whenever you're solving these type of equations is that you always want to get your equation to the most simple form. And after that, you're just going to want to isolate your variable on one side, and you want to put all of your constants on the other side. And yeah, so up first, we're going to be solving this very, very, very simple equation, and I'm just going to be working through a few like this. So we have 4x plus 5 equals 3 times 2x minus 9. First thing we want to do is we want to distribute. So we have 4x plus 5, that remains unchanged, but we're going to want to distribute 3 to the 2x, so it becomes 6x minus 27, which is just, 3 times negative 9. And like I said before, we want to just move all of our variables to one side. So let's add 27 to this side. We're just going to get 32. And if we subtract 4x from both sides, we're just going to get 2x right here. So this means that x is going to be equal to 16, and that's very, very simple. Alright, so moving on, we're going to be going to a little bit of a different type of equation, but it's going to have the same kind of idea. Okay, so we have x plus 5 divided by 6 plus 3x plus 9 divided by 5 equals 5x minus 3 all divided by 4. So the first thing we notice is that we have fractions, and whenever we have fractions, whenever possible, we want to get rid of that. So if we look at the denominators, we have 6, 5, and 4. And so the first thing we want to do is we want to multiply to get rid of this. And the number we multiply is just going to be the least common multiple of these three denominators, which in this case just so happens to be 60, right? So when we multiply by 60, we're going to try to simplify along the way, right? So let me show you how to do this. So we look at 60, right, and it's divisible by 6, and the actual answer to that is going to be 10. So we're going to take our 10 and we're going to just multiply it by the numerator, and we're just going to get rid of this denominator, right? So similarly, 60 divided by 5, this is going to be 12. So we take this and we bring down our numerator, and we just keep doing that. And this is a very simple way to actually start simplifying even before we multiply, right? Because if we just multiply this whole thing by 60, we're going to have some pretty big numbers, and we're still going to have our numbers at the bottom, right? So first, let's just distribute everything right here. Oh, I'm sorry. So this should be a plus sign. So we have plus 36x plus 108, and this is just all going to equal 75x minus 45. All right, so first thing, before we do anything, we just want to combine like terms. So our x's, so 10x and 36, that's just going to be 46x. Our constant value, so 50 and 108, that's just going to be 158. And our right side just remains untouched. So we just bring everything and rewrite it. So now that we have everything simplified, this is when we start to move our x values to one side. So first thing I want to do is I just want to add 45 to both sides. So I'm going to get 203 on this side and subtract 46 from 75, and we're going to get 29x. If we divide both sides by 29, we're just going to get x equals 7, and this is going to be our answer. All right, so let's continue moving on with a fairly similar type of equation. So let's do that. So first thing I want to do is I want to solve for, let's solve for z in this one. So let's solve for z. So first thing I'm going to do is I'm just going to write everything down. So z minus p over 4m plus 2z plus p over 3m equals 4z plus 3p over 12m. Alright, so now that we have this, you're going to notice that we have a lot more variables, right? We have a z, we have a p, we have an m, right? So this type of equation is going to be called a literal equation. And a literal equation is just a combination, it's an equation with a combination of numbers and letter constants, okay? And so it's still going to hold the same simplified form of mx plus n equals p, but this time we're just gonna have a lot more variables and stuff to worry about. Okay, but it's not any harder than just a simple linear equation. All right, so to solve this linear equation, again, we just want to find our least common multiple and multiply the whole thing by it. In this case, it's just going to be 12m, right? So everything is divisible by, so 4 is divisible, 3 and 12. So we're just going to multiply by 12m. Yeah, so 12m is divisible by this 4m, this 3m, and this 12m, and that's just the most simplified form. Right, so we also want to make note that we're solving for z, okay? Because we have so many kind of variables in this, we do want to make sure that we're solving for z. Oh, also, whenever you get a literal equation, the question is always going to tell you what variable to solve for, okay? So just pay attention to that. And it's not like you're going to get an equation you just don't know, okay? That's not how it works. So, again, 12m divided by 4m, that's just going to be 3. So we bring the numerator down. 12m divided by 3m, it's just going to be 4, so bring the numerator down. And 12m divided by 12m, that's just 1, so we don't have to do anything to this right side. Alright, so next what we want to do is we just want to distribute everything, so we're going to have a 3z minus a 3p plus 8z plus 4p. It's all going to equal 4z plus 3p. Alright, so then we just want to combine our like terms, so 3z and an 8z turns into a 11z. 4p minus 3p is just going to be p. And again, the right side remains untouched, so we just rewrite everything. Okay, so now that it's simplified, we are going to try to isolate our z, because that's what we're solving for. So 11z minus 4z is going to be 7z. And let's move p to the other side, so 3p minus p is just going to be 2p. Right, and so we just want to solve for z alone. So we're going to divide both sides by 7, and we get 2p divided by 7 is equal to z, all right? And so you'll notice that instead of it being like integer or another value, this is almost going to be like a ratio. It's also going to be like a relation of all these constants, okay? And that's just what a literal equation does. It's just a relationship between a lot of numbers, okay? So let's move on to a word problem now. Okay, so Ashley's dad agreed to put any dimes or quarters he received as change into a piggy bank so that he could buy a new video game. They agreed that when there are 200 coins in the bank, Ashley could have the money. They discovered that the number of quarters in the bank was 12 less than 3 times the number of dimes. How many coins of each type were in the bank? So first thing we want to do is we want to define a variable that we can use when we create an equation. So first thing we want to do is I'm going to say let's let d equal our dimes, all right? Our number of dimes that's what it's going to equal. Okay. So, and I say that because when the question told us the number of quarters, it was in relation to the dimes, right? So we just want to have everything in terms of dimes when we're creating this equation, okay? So now let's define, well, how many quarters do we have in terms of dimes, okay? So it says 12 less than 3 times the number of dimes, so this is just telling us that 3 dimes, 12 less than that, right? So that's just minus 12, okay? And we also are going to have a total of 200 coins. Whenever we have 200 coins, Ashley's dad is going to give it to us, right? So we have 200. Essentially, this is just going to equal our number of dimes plus our number of quarters, right? And so we want to know, well, how many of each type. So we just have to solve for either D or Q. But in this case, we can, instead of saying Q, we can just say 3D minus 12 because that's what Q is. And so from here, we only have one variable, so we can simply solve this. We're going to move 12 to the other side, and we get 12. 212 equals 4D, and we divide both sides by 4, and we're going to get D equals 83. Or I'm sorry, 53. Okay, so this is the number of dimes we have. And so from there, we can solve for the number of quarters by just plugging it into this equation. So we have 3 times D, or 53, minus 12. Okay, so we have 109 minus 12, and that's just going to be 147. I'm sorry. Quarters are just 147, okay? So this is our answer. So we have 53 dimes, and we have 157 quarters that Ashley is going to receive. Alrighty, let's move on to the next word problem. Alright, so the garden department at the Blue Box store is having a spring sale on plants. Stacy bought a total of 120 plants for a total cost before tax of $560. Now, Stacy only bought plants that were on sale for either $4 each or for $6 each. How many plants of each kind did she buy? All right, so again, we want to create a variable. So let's let P equal the number of, let's just say $4 plants, right? So we know that P is going to equal the number of $4 plants. So now we have to, in terms of P, we have to define, well, how many $6 plants are we going to have, right? So for the $6 plants, in terms of P, we're just going to have our 120 minus P, right? Because we know that regardless of how many of $4 or $6 plants we have, we're going to have a total number of plants of 120. So we just subtract the number of $4 plants to get our number of $6 plants, okay? So now that we do this, we're going to set everything equal to 560, right? Because that's how much all of our plants are going to cost. So now we're just going to plug in our values. So we have 4P, because remember, this is our number of $4 plants, times their cost, which is just $4, plus $6 for our number of $6 plants, which is defined by 120 minus P. Now all we have to do from here is just simplify down and solve. So we have 4P, and we can distribute this 6, so we get 720 minus 6P. And all we have to do from here is just continue simplifying, right? So let's move our 720 to the other side, so we get negative 160 equals a negative 2P. Once we combine this 4P and our negative 6P, we get negative 2P. And just divide both sides by this negative 2, and we get P equals 80. Okay, so we have 80 $4 plants. Now, to figure out our number of $6 plants, we just take this. So we have 80 for $4, and 120 minus 80, that's just 40. So we get 40 for $6. And this is just defined by 120 minus 80, okay? Because this is what we wrote up here as what the number of $6 plants is, okay? So this is essentially our answer right here. So we have just 80 plants for $4 and 40 plants for $6. All right, so let's move on to our last question. So we have Arlene and Martin have a video game library with 247 titles. They classify the movies by the era in which the movie was made. They have movies that are pre-1970s from 1970 to 2000 and movies made after 2000. So we have 3 different eras. So the number of movies they own that were made between 1970 and 2000 is 20 more than 3 times the number of movies that were made prior to 1970. The number of movies they own that were made after 2000 is 27 more than those in the library made prior to 1970. How many of each type of movie do they own? So again, let's first create our variable. So after reading this question, I noticed that they're putting everything in terms of movies made prior to 1970. So let's let P equal the pre-1970 movies. Okay, so P is going to equal the number of pre-1970 movies. So now that we know, well, pre-1970 is just P, let's figure out what's 1970 to 2000. Okay, so we need to define this number, this value of movies, in terms of P. So if we look right here, it says 20 more than 3 times the number of movies. So we have essentially 3P plus 20, okay? Now, to find after or post 2000, all we have to do is just read the question, right? It's telling us after 2000 is 27 more than those in the library made prior. So this is just P plus 27, okay? So to basically solve this, we have to look back and we realize that the total number of movies is just 247, right? So all we have to do is just set everything equal to 247 and add up, right? So 247, that's just equal to 3P plus 20, right? Because this is just basically this number is just telling us how many total movies we have, plus our P that we got from over here. So now we have to just simplify. 5P plus 47. And let's isolate our P, so let's move this 47 to the other side. So we just get 200 equals 5P. If we divide both sides by P, we're going to get 40 equals P. So this essentially means that, so I'm going to write it in a different color. So pre-1970s is going to just be equals 40, right? If we have from 1970 to 2000, that's going to be equal to 3 times 40, so we'll just put it right here, 3 times 40 plus 20, so that's just going to be 120, so that's going to equal 140. And we could just say post 2000 is just going to be equal to 40 plus 27, so that's just going to be equal to 67. Okay, so there we go, that's our answer. So we have 40 right here, 140 right here, and 67 right here. All right, so thank you guys for watching. This was an amazing video, and I hope you guys learned something about literal equations, maybe about how to analyze word problems, or just, learning more about simple equations. All right, so thank you, and stay tuned. Make sure to watch other videos from my Algebra 2 playlist. Bye-bye.